We're getting towards the later phase of the day, but we keep on swinging with the knowledge punches. I'm back with another one of our guest speakers. We've got Michael on the line, who is here to talk to you about the modern development of distributed applications. Take it away, Michael.
Thanks so much. Yeah, I'm Michael. I'm a software engineer at Google, and I work on the Service Weaver team. Today, I'll be talking to you about Service Weaver, which is a distributed systems programming framework written in Go. I'll begin with this talk, which will last maybe like 25, 30-ish minutes, and then I'll switch over and do a live demo so you guys can see what writing Service Weaver applications actually looks like. But we'll begin with the talk, and we'll begin in particular with a bit of motivation. So let's say you're writing some application, and to start, you're gonna write the application just locally on your laptop, let's say. Let's say the application is written in Go. Well, there's a lot of advantages to writing an application locally, and there's a lot of reasons why people do that when they start writing an application. The first is that it's easy to develop. If I want to write an app locally, I just sort of write normal code. I don't have to think about fault tolerance. I don't have to think about distributed system stuff. I don't have to think about serialization. I just write, the core business logic. Local applications are also easy to deploy. I'll just compile my application into a binary and run it like I would any regular binary. It's easy to test. I just write normal unit tests again and run them, nothing surprising. And it's easy to profile, trace, debug. All the tools you're used to, they all work locally just fine. So writing monolithic applications like this is super convenient. However, the reality is that eventually your application is going to outgrow your laptop and you're going to want to run it across multiple machines and you're probably going to want to run it in the cloud. Well, when we switch from developing locally to having to deploy in the cloud, we're going to run into a number of questions that we have to answer. For example, how should I structure my APIs? When I'm writing locally and it's just me, I can kind of change my APIs arbitrarily. They don't have to be perfect. But when we deploy something to the cloud, all of a sudden it becomes a lot harder to change these APIs. For example, if some other component or some other service is using my service and they're depending on my API, and if I change my API, I might break them. So because of this, APIs get a little more hardened, and because of that, I have to spend a little more time ahead of time thinking about what the API should be. I also have to start thinking about issues like scalability and fault tolerance, as well as security, all things that I wasn't really thinking about when I was deploying and running locally. There's also some organizational questions that I have to answer. How am I going to roll out different versions of my application? Should this be every day? Should it be every week? Which teams are going to be managing different parts of my app? Is it all one team? Or is the app big enough that I need to split across multiple teams? And even what languages should we use? We have to think about all these things. And today, I think it's very common for people to answer these questions by turning to microservices and using a microservice-based architecture. But when we do use microservices, we are again going to have a number of questions to consider. Specifically, how am I going to split my application into a bunch of different microservices? And the answer to this is not obvious. There's a lot of different ways to split. And I have to think about things like how big are my different microservices going to be? Do I want a lot or do I want a little? How are teams going to own different microservices? How am I going to roll out microservices? Things like that. How are different microservices going to communicate? But eventually you answer these questions to the best of your ability. You do split your application into microservices. But then you run into more problems. So for example, versioning. This is similar to what I was mentioning before. Let's say I have 20 different microservices. Well, these microservices are all independently deployable binaries, potentially rolling out on their own pace, which means I need to make sure that all the different versions of all my different services can work with one another. I can't just roll out a new version of a service and have it break every other version of every other service. So that's something that can be tricky to deal with. The next is observability. This is how do I know what's going on? We talked to some people who have, applications with a lot of microservices, and they're not even sure which microservices are talking to other microservices. So when stuff goes wrong, it's hard to figure out where exactly things were going wrong, how to find the root cause of bugs. Things like that becomes hard when you have a bunch of different services and maybe you don't own all those services. Testing is very challenging. Even running a big microservice-based application locally is hard. Testing it is even harder. Then there's performance, which is similar to observability. How do I find the bottlenecks? How do I know which components or which different services are talking to each other frequently? And also development velocity, similar to versioning. If I make a change to one of my microservices, how do I coordinate with all the different teams, all the different services to make sure that I can roll out this new feature in a seamless way? So because of all these challenges, people start to second guess their decision to split into microservices in the first place. They think, huh, maybe did I split too much? Was splitting maybe a little bit premature? Maybe I didn't split at the right boundaries. And often we find that people then start to merge their microservices back together. Uh, and this is kind of a vicious cycle between having an application, splitting it, realizing you split too much, merging different services together, realizing, huh, maybe I merged too much, splitting again. So this is a very complicated thing, and people get it wrong because it's very hard, and these things change over time as well. Well, with Service Weaver, the main goal of the framework is we want to get the best of both worlds. We want to have the advantages of a microservice-based architecture with all of the simplicity of writing monolithic apps. And in particular, we want to make it easier to make this decision of how do I split my application. And the way we're going to do that is Service Weaver applications are going to be written as logical monoliths. And then at runtime, you're going to make the decision of how you want to split those physically into different microservices. And this decoupling and the ability to delay your decision of how exactly to physically split your application is very powerful. And it's going to make a lot of these problems go away. All right. So the talk is going to proceed in 4 parts. The first part is development. This is how do I write Service Weaver applications? And again, just to reiterate what I just said, the core principle here is that a Service Weaver application is going to be written as a single monolithic application. It will, in one language, in our case Go, it will compile to a single binary. And what's even cooler is we're going to hide a lot of the distributed systems boilerplate from you. So you're not going to have to deal with serialization. You're not going to have to deal with a lot of networking code. You're going to write your app as if it's running locally. It's going to look like it's running locally at least. The next part of the talk will be deployment. This is now that I've written my application, how do I deploy it? And the thing to note here is even though Service Weaver applications are monolithic, they're written and compiled into a single binary, they are not run as a single binary. So the Service Weaver runtime is going to take your application, it's going to find all the different parts of it, it's going to rip them apart, and it's going to run them in multiple processes, potentially on multiple machines, in multiple regions in the cloud. And we provide a number of different ways to run these applications. You can run them locally to test things out. You can run them across a pool of machines using SSH, or you can run them in the cloud on Google Kubernetes Engine, for example. Next up, telemetry and testing. So this is, I've written my application, I've deployed it, and now I want to make sure it's doing what I expect it's doing. And when it's not doing what I expect it to do, I want to understand what's going wrong and why it's happening. And finally, I'll talk about performance. After you've written an app, you've deployed it, you've debugged it, you make sure it's working as you expect. You also probably want it to be performant. And I'll discuss a number of different ways that Service Weaver lets you write fast and efficient applications. All right, so let's get into the first part of the talk, development. This is how do I write Service Weaver applications? So the key abstraction of Service Weaver is going to be something called a component. And a component is not a microservice. There are some differences between the two, but I think if you're learning Service Weaver for the first time, it is helpful to think of a component like a microservice. If you're familiar with actors from actor-based systems like Erlang or Akka or Ray or Microsoft Orleans, a component is a lot like an actor. So essentially, a component is a computational entity. It can be replicated, they can fail and get replaced. They define interfaces, sort of like an API would define, sort of like a microservice would define an API. And these components are going to communicate with each other through these interfaces. And a Service Weaver application is going to be composed entirely of components. So components are sort of the key abstraction to keep in mind. We'll have a code generator which generates code for these components. So what does a Service Weaver application look like at a very high level? Well, I'm going to write my modular monolith, my modular binary, and it'll define a number of components. So for example, here we have a rock component, a paper component, and a scissors component, and you would define their interfaces and their implementations and whatnot. Then we're going to compile this to a single binary, as I said, and we have a number of different ways we can deploy it. If we run it locally, then maybe all three components are placed in the same OS process locally just for testing, and all the communication between components is done directly as method calls. But I can take the same binary and instead run it distributed. So now maybe the rock and paper components are placed in one OS process on one machine, but the scissors component is replicated across multiple machines. And now when we have a method call between two components on two different machines, they're executed as remote procedure calls rather than as local direct method calls. So that's components at a high level. Now let's take a deeper look at exactly how we define them and how we implement them. So first, we'll look at an example here. This is a cache component. The first thing we're going to want to do when we implement a component is define its interface or its API. This is like how any microservice needs some API that other services use to interact with it. Here, the interesting thing is we're implementing this cache component as a regular Go interface. So here we say type cache interface. It's just normal Go. And this interface is going to have a bunch of methods, put, get, whatever. Here we just show put. And you'll also notice that these methods, their arguments are normal Go language types. So here put takes a key and a value, both string. So I don't have to deal with having protobufs or Captain Proto or any other sort of serialization format. I'm just writing normal Go code. Next, after we define the interface of the component, we're going to have to actually implement the component. And as you might guess, if an interface is defined as an interface, an implementation is going to be defined as an implementation. So here we have a struct called cache, which implements the cache interface. The only thing noteworthy here is that we have to embed this weaver.implements field inside of the cache struct to signal to Service Weaver that this struct implements the cache interface. But other than that, everything is normal Go code. So I implement methods on this cache struct. I store my data in a normal map. If you were to look at this, you wouldn't really even realize has a bunch of distributed stuff underneath. Next, how do we actually run our apps? Well, we're going to have to define a main component that sort of represents the core logic of our app, the entry point into our application. Here we're calling that app, and we embed this weaver.implements, weaver.main to indicate that it's the main component. And then also we have to have a weaver.ref, a reference to the cache. So when we have a field like cache here, it says, hey, I'm a component and I'm going to go talk to this other cache component. So please give me a reference to it. And then finally, we have our main, we call weaver.run, which will get passed an instance of our app. Then we can use the app to get the cache reference and call methods on it. And again, here, when I call cache.put, this looks like a normal method call. Again, I'm not seeing a lot of serialization or networking. All that boilerplate is hidden away from you. And this should hopefully to you look just like sort of normal basic Go code. So this is just one component, the cache component, but in reality, your application would consist of a lot more components, whatever components your application needs, and they're all going to be communicating with each other. They'll all have references to each other, and they'll talk to each other. All right, so that is how do I write a Service Weaver application. Now we'll turn to how do I deploy a Service Weaver application. So the first thing we're going to want to do is write a very small config file. In its simplest form, the config file is just going to say, what is the binary that I want to deploy? That's just the binary that we compiled our monolithic application into. And then we just do go run dot. And I think if you just sort of look at this superficially, it's not super, noteworthy. It doesn't stand out. But I actually think this is one of the most powerful features of Service Weaver and one of the things that we've been enjoying the most. So imagine you're managing a microservices-based application with like 20 different microservices. So every microservice compiles to its own binary. Maybe they're written in different languages. They have their different build systems, and I want to run it locally. That can be a huge nightmare. I have to figure out how to build every different service. Some of them may not be well documented, and then I have to go and figure out how to run all of them in the right order with all the right config to make sure they talk to each other. And it can be a nightmare to even just run something locally. But with Service Weaver, because everything's compiled into a single binary, you can just run go run dot, just like that, and it just works. And we found so far, we've been porting a lot of apps to Service Weaver. This is super powerful. It really speeds up development. It makes everything so much more seamless. But it goes beyond just simplicity and locally running stuff. We can also run in multiple processes without having to change the application or the binary at all. So we have a Weaver multi-deployer, and if you run Weaver multi-deploy and you pass it this config file, weaver.toml, now instead of having every component run in a single process, we're going to have every component run in a different process, and the components will communicate with each other over localhost using remote procedure calls. This is, again, mostly for testing, just to make sure your app can work when it's distributed and not sharing any memory. Next, the SSH deployer. You'll have to add to your config a file which lists all the IP addresses of some pool of machines. But then you can run Weaver SSH deploy. And now we're going to take all these components, run them in separate processes across this pool of machines. And this is a more realistic deployer. Maybe you would actually want to run this in production. And finally, the most sophisticated, the GKE deployer. GKE, or Google Kubernetes Engine, is Google Cloud's offering of Kubernetes. And here in our config, all we have to do is say what regions do we want to run in. We support multiple regions. You can have multi-region deployments. That's pretty cool. And you have to give the URL where you want your listeners or your HTTP endpoints to be available. And then all you have to do is Weaver GKE deploy weaver.toml, and your application will get run in the cloud. Different components will be run in different pods, and everything will just work. And again, note that these different deployments, I'm not changing my application. I don't even have to recompile it. The same binary, the same app, the same logic is going to work with all these deployers. And we have some more sophisticated configuration options. You can specify manually which components you want to co-locate together. For example, maybe I say, okay, rock and paper should be together, scissors should be separate. All right, so what do these binaries actually look like when they're deployed? Well, we again have our modular binary, our single binary that has all the components defined in it. And then at runtime, different components are going to be placed into different OS processes. And the way this works is that your binary links in the Weaver code, the Service Weaver library. And this code is going to have a small little agent called a weavelet that is running on your behalf. It's in the background. It's like a daemon process. And this weavelet, this agent, is going to communicate over a well-defined API with the deployer. And because we have this well-defined API, there's not a single deployer implementation. You can have any deployer implementation. So for example, our SSH deployer implements the API in one way. It says, okay, when I want to start something, start it over SSH. Our GKE deployer implements the same API, but in a different way. It'll run things in pods on GKE. So this abstraction layer between the code, which is sort of what you want your program to do, and the deployer, which is like, where should it run, is super powerful, and it enables this portability, and it enables the fact that we can have a bunch of different runtimes. And so if you're a company, a small business, and you're thinking about using Service Weaver, for example, you can take one of our deployers and use it straight up. You could write a deployer from scratch, or you could take one of our deployers and modify it slightly to meet your needs and to deploy in exactly the way that you're used to deploying. So we find that this API is super powerful. It's sort of analogous to Kubernetes, but at a higher level. Kubernetes abstracts away a lot of the physical details of a cluster. This API that I'm describing here is similar, except it's being embedded directly into the application, and it's a bit at a higher level. And you can see that because our GKE deployer, in fact, is implemented on top of Kubernetes. All right, so this is what an application looks like when it's actually deployed. Now let's move on to telemetry and testing. This is making sure my app does what I expect it to be doing. The first thing here is logging. We have an API for logging. That is not particularly noteworthy. In fact, we use a standard logging interface, so there's nothing really novel there. But the cool thing is what happens to those logs. And what happens to the logs depends on where you deploy your application. So if I run my application locally, those logs are probably going to be printed to standard out and maybe saved as some files. But if I take that very same application and I run it on GKE in the cloud, the deployer is going to take my logs and automatically export them to Google Cloud Logging, for example. So this is super powerful. It means I just log. I don't have to think too hard about it. And wherever I deploy my application, those logs are going to be seamlessly integrated into the environment where I deploy. Next up is metrics. Very similar story. We have an API to define things like counters, gauges, histograms. And again, the API itself is not particularly novel. That's kind of the point. But what happens to those metrics depends on the environment in which you deploy. If you deploy locally, then those metrics are going to be exposed on some HTTP endpoint that you can hook up to something like Prometheus. When you deploy on the cloud, those metrics are automatically exported to Google Cloud Metrics, where you can view them, query them, graph them, set up alerts, anything you want to do. Tracing, very similar story. We have an API to automatically trace all method calls between components. If you run locally, you can use tools like Perfetto or Jaeger to view the traces. And when you run on the cloud, these things are going to be exported to Google Cloud Tracing. Next, we have profiling. I think this one is pretty cool. Go has good support for profiling binaries. You can run a binary and say, hey, take a CPU profile or take a memory profile. Service Weaver extends this one step further. If I'm running an application and it's being split across a bunch of different machines, I can say, take a global profile. So it's going to go to every single running binary, take a profile, aggregate all those profiles together, and hand it to you. So you can see the performance of your application as a whole. And this is super useful for finding things like bottlenecks to say, okay, I profiled this binary, but I'm not even sure if it's the bottleneck. With the global profiling, you can see everything and see, okay, this component on this machine is actually the bottleneck. Next up, we'll just show you some examples of what some of our debugging and monitoring tools look like. This is a screenshot from one of our dashboards. The UI itself is not super sophisticated, but I think the content is cool. Here we're showing a call graph of all the different components. So the cool thing about Service Weaver, as you saw when we sort of started writing components, is that every component declares ahead of time which other components it's going to talk to using references, weaver.ref. This means that we know ahead of time, at compile time, we can actually extract the entire call graph of your application. And I was mentioning earlier that for a lot of people with big microservice-based applications, they don't even know which services are calling each other. So this is already super powerful. And then at runtime, we can automatically add metrics to measure things like how many times are different components talking to each other, which methods are they calling, how slow are the methods, how many bytes are these method calls using. And so because of that, you get this bird's eye view into your application. You can really see, okay, which components are chatty, which one seems like the bottleneck, and so on. Over here, this is a picture of Perfetto. It's a Google tracing tool that runs in your browser that you can use to view traces locally. And again, just reiterating, we integrate with things like Perfetto, CloudTrace, Prometheus, Metrics Explorer, Logs Explorer, stuff like that. All right, testing. I think this is very cool, just like Go Run. I've said this before, but I think it's worth repeating that if you have a microservice-based application with a bunch of different services, it can be a pain to run locally. You have to build a bunch of different binaries, make sure you run them in the right order. Testing is even harder. I have to run it locally, and then I have to write my tests. Somehow, I probably need some external testing framework. It's kind of a pain in the butt. But with Service Weaver, again, because everything is a single binary, I can just write normal unit tests. And these unit tests are going to exercise the entire application. So my unit tests kind of actually become more like end-to-end tests. And again, that is super powerful. Just like go run dot, being able to run go test dot is super, super, super helpful. All right, then the last section is performance. Service Weaver has a number of different features which enable you to write fast and efficient applications. The first two is custom serialization format, and the second is a custom transport RPC protocol. So Service Weaver does not use gRPC or RPC or any other existing serialization formats or RPC protocols. We implement our own that are actually faster. And the reason that they're faster is not because somehow we're a bunch of engineering geniuses. The RPC team, the gRPC team and the protobuf team, they've spent a long time optimizing things and they're extremely smart. But the thing that we're doing is we're taking advantage of the specific assumptions of our applications. So for example, because an application is a single binary and we deploy it atomically and we make sure that all the components are running at the same version as part of the same binary, we don't have to worry about versioning. So with protobufs, if you're familiar with them, the wire format has to have things like field tags and type information, and it has to be careful that if I'm running a slightly older version of the same protobuf file, I can still talk to you. We don't have to worry about that because we make sure everything is running at the same version. So those are kind of the assumptions that we can take advantage of to optimize our protocols even further. Next is co-location. I showed this a bit when we talked about the config. It's the ability to say, I want to run these two components in the same OS process. And when they do that, they communicate via direct method call. So there's no overhead at all of serializing any arguments or returns. There's no networking, not even into localhost. There's no context switching into the operating system. They execute as a direct method call. And this is super powerful, getting back to the motivation of allowing you to defer the decision of how do I split my application into microservices. Because with Service Weaver, you can split your application into any number of components that you want. And then only later at runtime, after you have the experience running your app and seeing actual empirical data, can you decide, okay, what is the best way to physically split my application? And maybe I have 20 different components, but I think to myself, oh, actually the most efficient is to have only 2 separate physical processes. That's totally fine. You can co-locate all your components into only 2 processes. And the ones that aren't co-located, there's no performance overhead to that at all, like I just mentioned. So it's as if you never split them in the first place. So this is a super powerful feature which lets you defer the decision of how exactly do I physically split my application, and instead you only focus on what is logically the best way to split my application. And finally, routing or sharding. We allow different components to be sharded. So if I have a cache, for example, I might want to say, okay, every request to the same key should go to the same replica. And that way I increase my cache locality. I'll show you some benchmark numbers. I'm not going to dwell on them too much. I won't bore you by going into the details. But we took an existing application. It's called Online Boutique. It's from Google Cloud. It has 11 different microservices. We ported the Online Boutique application over to Service Weaver, and we ran it in 2 ways. First, we ran it with every different component run in its own process on GKE. And the second, we merged all the components into the same OS process on GKE. If we compare the original Online Boutique with the Service Weaver version co-located and the Service Weaver version unco-located, we see that we use less code, way less config, we have no protobuf, we are 4 times more resource efficient, so we have 4 times fewer machines to handle the same throughput, we have 7x better median latency, and 37x better tail latency. So again, I'm not going to bore you with the details. You can look at the slides afterwards or contact us. But the point is, it's fast. All right, so that concludes the talk portion. I hope you find that Service Weaver is a framework which makes it easy to develop, deploy, and monitor applications with high performance. And with that, I'll switch over now to a quick little demo where I'll show you how to actually write Service Weaver applications from scratch. So in this demo, we're going to develop a very simple application. The application it's also going to do is reverse strings. So if I type foo, it gives me oof. And this right now is running at reverser.serviceweaver.dev. So if you want to play with this application, you can. I'm biased, but I think it's fun to type in here. So I'll show you how to implement this application. And I'm going to go through it, but if you have any questions or you want to refer to it again after the talk, the source code is online on our GitHub at github.com/serviceweaver/weaver. It's called Reverser here, so you can check it out. Okay, but with that, let's go ahead and jump into the code. As I mentioned, we're going to write an app to reverse strings. So the first thing we're going to want to do is implement a component that reverses strings. That's not too surprising. Maybe I should zoom in just a little more. So here we're going to define our reverser component. We'll start by defining the interface. So I say reverser is some interface, and it has a method called reverse, which takes in a string and returns the same string reversed. Then we'll have our reverser struct. It embeds this weaver.implements reverser to say, hey, I'm the struct that's implementing the reverser interface. I am the reverser component implementation. And then we implement the reverse function. And this is just normal Go code. I take a string, I turn it to a list of runes, I reverse it. Nothing, it's not rocket science. And also, maybe I want to make sure I know what's going on with my application, so I'll define a metric. So here we have a histogram. It's called reverse string length, and it's going to measure the length of all the strings passed to the reverse method. And here in the body of the reverse method, I take the string s, I compute its length, and I add it to the histogram. Simple as that. So here we have an entire component with a metric in 50 lines of code, including this big copyright thing at the top. That was simple. I hope you found that simple. Now let's look at our main. Top, we have some stuff for parsing the address of our server and some things to embed the front end. Next, in our actual main, we call weaver.run, and we pass it this serve function. Down below, we have our serve function. It takes a server. This could also be called app or main or something like that. This is implementing weaver.main. So this is saying this is sort of an entry point into our application. And because we're going to want to call the reverser component that we just implemented, we have a weaver.ref to the reverser component. Next, inside the actual serve function here, we're going to get a network listener because we're going to run an HTTP server. That's not super interesting. And then again, we serve HTTP traffic on it. Again, this is not super service weaver specific. The only thing I'll point out is right here where we call the reverse method. So on the reverse endpoint /reverse, we'll get a string, we'll pass it to the reverse method and get back the response. And again, if this is running locally, then this reverse call is going to be run directly as a method call. But if I run it distributed, this will be run as a remote procedure call. And that's it, 78 lines of code, none of which is too service weaver specific. For that, if I do go run dot, just like that, it says the listener is available on port 9000 and everything is running. So let's go ahead and take a look at that. I'll go to port 9000 and you see I have a version of the app running locally. So that's cool. If I go back here, I can run weaver single status. You see that we get information about the application. So here it says we have an app. It's called Reverser. It's 18 seconds old. It gets a unique ID. And it has these two components, reverser.reverser, I showed you that, and the main component. And we see the PIDs, the process IDs of the replicas. So here we see that every component has one replica, and they're running in the same OS process. That's why they have the same PIDs. We also see here, in case we forget, that port 9000 is where the listener is available. All right, so let's kill this. Let's go ahead and look at our config file, weaver.toml. We have a GKE section here at the bottom, but we can ignore that for now. Really, the important thing is these first two lines where we say the binary reverser is the one we want to deploy. And then with that, if I build my application and I do weaver multi deploy, it says the application is deployed on port 9000. So let's try that again. And again, we have the same application now running locally, but instead of in a single process, it's running across multiple processes. And I can see that if I do weaver multi-status, same UI as before. We have an app called Reverser. It's 17 seconds old. But the thing here now is we have our two components again, main and reverser. But when we look at the PIDs, we see that both of these components are replicated twice. That's why there's two PIDs. And all the PIDs are different. That's showing that every single component is running in a different OS process. And again, the port 9000 if we ever forget. We can also take a look at that metric that we define, reverse string length. So if I do weaver multi-metrics and I search for the metric that we defined, reverse string length, we see that there's 4 virtual nodes here. Those are the 4 processes. We see that 2 of them have no metric information. That's because they're running main, not reverser. And the ones that are running reverser, we see that they have an average string length of about 50. So let's go back to the application, and I'm going to spam a bunch of big text into the app. Now, if I do weaver multi-metric string again, we see that the average string length has increased by about 10x. So this is a rudimentary way of looking at metrics. You probably wouldn't do this in any realistic setting. It's sort of just to quickly debug stuff. More realistically, you could hook this up to something like Prometheus and get a view of all the graphs of all the metrics. Okay, so that's how to take my application and run it locally in a single process and how to run it in multiple processes. But I think the most realistic and the most interesting thing is actually to run it in the cloud. So to do that, like I mentioned earlier, we'll have to add a little GKE section. We say which regions we want to run in, the URL where everything's available. And then I'll make sure my application is built. I'll do weaver GKE deploy, weaver.toml. And what this is going to do is it's going to take my application, it's going to put it in a container, it's going to upload the container, it's going to create a bunch of Kubernetes clusters in the cloud in the project that I said. It's going to set up a bunch of networking stuff, yada, yada, yada. Some of these things are a little slow. Creating clusters and whatnot takes time. It's a little bit hard for us to avoid. But before this talk, I went ahead and ran this. And you can see in Kubernetes, this is the Cloud Console. You can see a bunch of different jobs running. And the details of this are not super important. Normally, as a user, you wouldn't even be looking at this stuff. But just to show you that it's real. And in fact, those Kubernetes jobs are implementing this reverser.serviceweaver.dev website that you can play with yourself. And this is running the exact code that I just showed you. So if you were to walk through what I just said in the last like 8 minutes, write that code, run the commands that I ran, you would get this application right here at reverser.serviceweaver.dev. So I hope that sort of shows the simplicity of going from a simple app, running locally, testing it locally, looking at metrics, and then deploying it on the cloud without a lot of headache. You don't really have to fuss with a lot of stuff. And if I had more time for the demo, I could even show you, we could go into GKE and look at, for example, the integration of that metric into Google Cloud Metrics, the integration of logs, we could look at traces, all those sorts of things. But in the interest of time, I think I'll start to wrap up. If you want any more information about Service Weaver, if you want more information about the demo, or you want to learn anything, you can visit our website at serviceweaver.dev. You can also leave an issue or comment on our GitHub. We have a Discord you can drop in and chat with us as well. We are actively looking for customers. So if you are interested in using Service Weaver in any capacity, big or small, the team is very eager to collaborate. We're happy to meet with you. We're happy to figure out the best way to use Service Weaver. We're happy to integrate features into Service Weaver that suit your needs. We can tweak deployers, things like that. I think any collaboration would be super mutually beneficial. We think Service Weaver is a really helpful, really powerful tool. And we hope you think that too. So if you're interested at all, please, please, please definitely reach out to us by any means. You can reach out to me, the team, go to the website, go to this contact us. We'd love to hear from you. We'd love to work with you. And with that, I think I'll end there. And if anybody has questions, I think you should be able to post them and I'll get them relayed to me and I can answer them.
Yep. There's a Q&A tab, folks, so go in there and type any questions you have. Great to learn all about that, Michael. I guess, kind of open up, let you do a little bit of a sales pitch for more if you want. Service Weaver, it came from a requirement somewhere, right? Are there existing products that you feel like this does a better job than, or do you see this as a completely new area of the market you're trying to tap?
Yeah, great question. So one of the core ideas that we have, which is sort of decoupling the logical boundaries of your program and the physical boundaries of your program, that is, we think you should just focus on writing components in the best way that logically makes sense and defer the decision of physically how to run them. That idea has existed forever. If you look at databases, operating systems, data processing systems like MapReduce, Spark, this idea is sort of fundamental to all of those ideas. So we're really just taking that same idea and existing it to this new domain of serving systems, sort of general purpose serving systems. Certainly there are things like actor frameworks I mentioned earlier, Ray or Leans, which are similar, but I think we have a more focus on how do you realistically write an application? How do we keep our API simple? How do you deal with deployments, rollouts, metrics, all these things that are really important to get right if you want to use this for real.
Okay, that's fair. I think we're a little bit slow on the questions today. Oh, wait. I see. People maybe put it in the wrong tab. So I think Amos was asking, can I configure an app with a shared state? For example, same database. Should I be aware of any concurrency issues?
Yeah, great question. So definitely you can have a shared database for sure. In fact, that's sort of our intended way of using things. One of the interesting, maybe controversial features of our system is we actually don't have a lot of features baked into the system to handle persistent state. But we did that intentionally. There's a lot of frameworks which do allow you to do some special state management, but we find that state and data is such a complicated and such a vast space that trying to have an opinionated approach on that is sort of a fool's errand and it's destined to fail. And we actually believe that we should leave it up to the developer to use any sort of distributed database, any state that they want to use. Whatever they use now, they can use that with Service Weaver as they normally would. So yes, you can definitely use shared state. In terms of concurrency, I wouldn't say we introduce anything new that you have to think about. Components can be run, the methods can be run concurrently. You have to be aware of that, just as you would any sort of microservice, which is handling multiple requests.
Okay. And looks like we have another one coming in from Million. They asked, do you want to expand this to be able to be deployed besides GKE?
Yes, great question. So definitely. So I'll first note that we already can deploy besides GKE. We have a local deployer, we have the SSH deployer, we have our GKE deployer. We actually have a GK local deployer, which simulates GK deployments online. We're actively working on an AWS deployer as well, and some more other deployers in the works. So yes, for sure, 100%. And if you're interested in implementing your own deployers, we have that API I mentioned. We have a blog post explaining how to do it. We're happy to work with you how to do it. So definitely the sky's the limit in terms of deployers.
Awesome. I think that does conclude it, though. If people want to reach out to you, you do have means for them to talk to you more about this, right?
Yes, definitely. So if through like the conference website, you can either get my contact, or if you just go to contact us, you can go, we have a bunch of different ways to contact us. Or if you go to the GitHub, you can just leave an issue or something. Definitely please reach out. We'd love to hear from you. Positive or negative, any feedback is super appreciated.
Yeah, man. Hey, I've loved the energy you've brought to this subject. Right? I can tell you're passionate about it, and I'm looking forward to seeing what you guys can do with it in the future. But I think what we'll do now is we've taken up plenty of time. We're going to wrap it up. I'm sure if people have more they want to learn about, if they want to get involved, they have the means to do so. But thank you, Michael.
Sweet. Yeah, thank you. Thanks everybody for watching. Appreciate it.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and high on illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh, we don't need to say we're sorry. We don't need to worship heaven's heart. We don't need to say we're sorry.